When we talk about the edge of the universe, we are not talking about a physical border, not a wall, not a shore, but something far stranger. We are talking about the edge of light itself, the farthest distance photons have traveled since the birth of the cosmos. Beyond that horizon, reality continues, stretching into a domain we can never reach. Most of the universe lies forever hidden from us, not because it is too far away, but because it is too young for its light to have arrived. The universe expands faster than information can travel across it. Imagine a vast room where the walls move outward faster than you can walk. No matter how long you chase, you can never catch up to the frontier. This boundary is not the same for everyone. Someone living in a galaxy billions of light years away would have a completely different observable universe. Their cosmic horizon captures areas we will never see, and ours captures areas they will never see. Each observer is positioned at the center of their own visible sphere. There is no true center of the universe, only centers of perspective. Every point in space sees a different version of reality, and together they form a cosmic mosaic of infinite viewpoints, infinite horizons. The expansion of the universe does not simply push galaxies away, it stretches the very fabric of space. The more distant a galaxy is, the faster it appears to be moving. At unimaginable distances, galaxies recede faster than the speed of light. This is not because they break the laws of physics, but because space itself expands between us. In those regions, even if a star exploded with the brightest light in existence, that light could never reach us. It is like watching a ship sail toward a waterfall that moves backward as fast as the ship sails forward. This cosmic speed limit shapes the universe in profound ways. As time stretches on, more galaxies slip beyond our cosmic horizon. Their light grows fainter, more stretched, until eventually they disappear altogether. Every second of cosmic time pushes more of the universe beyond our reach. In the far future, long after our sun has died, the distant galaxies we see today will no longer be visible. They will slip beyond the horizon, leaving behind an empty darkness. The universe will appear cold, silent, and lonely, not because it is empty, but because expansion has erased its visibility. This idea alone is staggering. We live in a fleeting era when the universe is still visible. We exist in a cosmic moment when galaxies are still close enough, bright enough, young enough for us to study. Billions of years from now, the universe will not look anything like it does today. Civilizations born in that distant future will see only a dark sky with a few local stars. They will have no evidence of the Big Bang, no cosmic microwave background, no galaxies beyond their own. They will assume the universe is static, isolated, and empty. They will never know the true vastness of creation. In a profound sense, we are lucky. We live in a time when the universe is still revealing itself. But perhaps the most mind-bending realization is this: the observable universe may be just a single patch in a much larger cosmic landscape. During cosmic inflation, the universe expanded faster than light could travel, stretching tiny quantum ripples into enormous cosmic structures. But inflation likely did not happen everywhere at once. Some regions expanded into universes like ours, while others expanded independently, forming separate pocket universes. These pockets may be forever separated by regions of space still undergoing inflation. We are trapped in our bubble, unable to reach the others. Beyond our cosmic horizon might lie entirely different universes, each with their own galaxies, their own physics, their own cosmic history. Imagine it. Beyond the horizon lies not only more of our universe, but perhaps a horizon beyond that, and beyond that, like layers of existence stacked upon one another, stretching into infinity. In these unreachable realms, stars may burn differently, galaxies may form in impossible shapes, and physical laws may differ so dramatically that we would not recognize the fabric of reality. Some universes might expand more slowly, others more quickly. Some might end in fiery collapse, others in eternal expansion. Some might produce life, others might be forever empty. And yet, all of this is hidden behind a curtain we can never lift. It is a strange feeling to know that most of the universe lies beyond our reach, forever invisible, forever silent. But that knowledge does not diminish the grandeur of what we can see. If anything, it makes our tiny sphere of visibility even more precious. When we stare into the night sky, we are not just looking into space, we are looking into time itself. The farther we look, the deeper into the past we see. And at the edge, where the faintest light barely reaches us after 13.8 billion years, we find not the end of the universe, but the beginning of our own visibility. Beyond that lies a darkness, not because nothing is there, but because everything is out of reach. The farthest galaxies appear as tiny smudges of ancient light, stretched thin by billions of years of travel. Their shapes warp, their colors fade, their forms dissolve into red, shifted whispers. These faint signals are so old that they come from a time when galaxies were young, messy, chaotic, nothing like the majestic spirals we see closer to home. They flicker like ghosts from an era long before the Milky Way existed. And beyond them, there is silence. Not because space ends, but because light simply hasn't reached us yet. If you could stand at the far edge of the observable universe, the view would still not end there. From your new position, the horizon would stretch yet again, revealing regions forever invisible to us here on Earth. The real universe, the total universe, is not a sphere centered on us. It is an endless expanse where each observer sees only their own island of visibility. Imagine trillions upon trillions of observable universes, each belonging to a different point in space, each one overlapping slightly with its neighbors, but also containing regions no one else can ever see. It is a cosmic mosaic where no single being, no matter how advanced, can witness the entire grand design. And yet, even within our limited horizon, something remarkable happens. As galaxies move farther away, the expansion of space pushes them into a zone where their light becomes so stretched, so faint, that it eventually disappears. With every passing second, the universe you and I can see becomes smaller, not in size, but in content. Some galaxies visible today will vanish from view in a few billion years. They will not explode or fade, they will simply be carried away by expansion faster than their light can return. Over time, the universe removes them from our sight, slowly dimming its own lights, revealing less and less of its true nature as time moves forward. At the heart of this mystery lies the event horizon of the universe. The event horizon is not something we can touch, not something we can cross. It is the point where the expansion of space outruns the speed of light, a cosmic boundary beyond which events can never influence us. Any galaxy beyond this line becomes permanently disconnected. It could burst with incredible brightness, collide with another galaxy, form millions of stars, or even give rise to civilizations. But we will never see it. Those events are lost to us, sealed behind a horizon we can never breach. This raises a profound question. If we cannot see those regions, how do we know they exist? The answer lies in the early moments of cosmic inflation. Inflation stretched space so dramatically that tiny fluctuations in the primordial universe became the seeds of galaxies, clusters, and stars. The patterns of those fluctuations are imprinted in the cosmic microwave background, the ancient afterglow of the Big Bang. These patterns suggest that inflation did not happen in a small region, but everywhere. They tell us that the universe is far larger than the part we can see. They whisper that beyond our horizon lies a continuation of the same vast cosmic tapestry, more galaxies, more clusters, more dark matter shaping unseen realms of existence. But what if beyond that lies something entirely different? What if somewhere past our cosmic horizon, inflation did not slow down the way it did here? What if it continued forever, creating new universes endlessly, each isolated from the others by walls of expanding space? This is the idea of eternal inflation. It suggests that the cosmos is not a single universe, but a vast multiverse, a landscape of universes, each one a bubble floating in an endless sea of inflating space. In some bubbles, the laws of physics may look similar to ours. In others, they might be completely alien. There could be universes with no stars at all, universes where gravity is too strong for galaxies to form, universes that expand too quickly for life, universes that collapse in seconds, and universes that last trillions of years. Somewhere, far beyond anything we can ever reach, there could be universes where the physical constants allow life to flourish in ways we cannot imagine. Perhaps there are regions where the speed of light is different, where time flows more slowly, where atoms behave differently. The multiverse theory suggests that our universe is not unique. It is one of uncountable variations, one possibility among infinite possibilities. And the edge of our observable universe is not the edge of existence. It is simply the edge of what our universe allows us to see. Of course, there is another possibility, that beyond the cosmic horizon lies a structure we have never encountered in physics. Perhaps space becomes curved in ways we cannot detect. Perhaps there are higher dimensions folded just beyond our reach. Perhaps the universe loops back upon itself, forming a shape so vast that it appears infinite even though it is not. There might be cosmic walls, voids larger than superclusters, or regions where dark energy behaves differently. There might be gravitational fields strong enough to warp the expansion of space itself. There might be physics that has no parallel in our part of the universe, forces, particles, or energies that remain invisible because they exist in a realm forever separated by the flow of cosmic expansion. When we stand inside our bubble of visibility, staring into a horizon we cannot cross, we are seeing only a tiny fraction of a reality far larger than human imagination. The edge of the universe is not an end. It is a beginning, a threshold, a frontier that calls to us with a silent question. If this is all we can see, then how much more remains hidden? The universe is not something we stand outside of and observe. It is something we are woven into, something we belong to, something that created the very atoms that allow us to understand it. And when we ask what lies beyond what we can see, we are not simply asking a scientific question. We are asking a question about ourselves, about our place in a universe far vaster than our senses can grasp. The edge we speak of is not a cliff in space, but a limitation of our perspective, a line drawn not by stars or galaxies, but by time and light. What actually lies beyond that unreachable frontier? In our minds, we try to imagine it. More galaxies drifting silently in the darkness, more clusters of stars forming the grand architecture of cosmic webbing, more great empty voids between them. But perhaps the universe changes subtly on the other side. Perhaps the distribution of matter shifts. Perhaps there are regions where galaxies form differently, where stars burn hotter or colder, where cosmic evolution unfolds in ways we cannot predict. The universe may be filled with colossal structures that remain forever unseen, superclusters that dwarf even the greatest structures we observe, cosmic rivers of galaxies flowing into gravitational oceans, or expanses so empty and dark that even light avoids them. All of this might exist, but expansion ensures it will never touch our world. Yet the greatest mystery may not lie in the repetition of galaxies or the familiar shapes of cosmic structure. It may lie in the idea that, beyond our horizon, the laws of physics themselves might shift. Perhaps dark energy behaves differently in distant regions, altering the fate of space and time. Perhaps dark matter forms structures we cannot imagine. Perhaps new particles, new forces, or new dimensions influence the formation of galaxies in ways our science has not yet conceived. Imagine regions where gravity ripples differently, where quantum effects scale to sizes we cannot fathom, where time flows at a different pace. If the universe is truly infinite, then every possibility allowed by physics might be realized somewhere beyond the edge of visibility. Some theories suggest that space itself may fold in complex shapes beyond our view, curving into higher dimensions that we cannot perceive. In these hidden dimensions might exist forms of matter and energy we have no name for, realities that occasionally brush against our universe, leaving subtle clues in the cosmic background radiation. Others propose that the universe might loop back on itself in ways we cannot yet detect, forming a cosmic architecture so vast that our observable region is like a single grain of sand on a boundless beach. But perhaps the most profound truth is this: the universe doesn't need to end for mystery to exist. Even the part we can see holds more stars than all the grains of sand on Earth. Even the galaxies we observe contain wonders beyond anything our minds can fully imagine. Yet what lies beyond the cosmic microwave background, beyond the last faint galaxies, beyond the thinning red-shifted light, is a realm that belongs solely to possibility. It is the domain of the unseen, the untouched, the unexplored. It is a place where theory takes over, where imagination becomes a scientific tool, and where humanity must accept that some things may remain forever out of reach. Even so, the edge of the universe is not a dead end. It is a beginning, a challenge, a cosmic whisper that tells us there will always be more to search for, more to question, more to dream about. The true beauty of the universe lies not in its vastness alone, but in the fact that no matter how far we look, there is always farther to go. No matter how much we discover, there is always more waiting just beyond the frontier. And no matter how powerful our telescopes become, the ultimate horizon will always remain a silent reminder that the universe is larger than all of us, larger than our thoughts, our dreams, our lifetimes. What lies beyond the cosmic horizon may remain hidden forever, buried in the darkness of unreachable space. But the desire to understand it, to imagine it, to chase it, is part of what makes us human. It is part of what gives our existence meaning. The idea that the unknown is not something to fear, but something to explore. That every question leads to another, every discovery to a deeper mystery. And so, as we stare into the night sky, into the faint glow of galaxies 46 billion light-years away, we are not just looking at stars. We are looking at the edge of knowledge itself. Beyond that edge lies a realm we cannot see but can always wonder about. A realm where galaxies may be born, where universes may collide, where physics may break and reform into shapes we have never imagined. And in that vast, unreachable silence, the universe continues, expanding, evolving, creating, destroying, far beyond the reach of our eyes, but never beyond the reach of our curiosity.